Hi, my name is Evan McNamara, and here's my BME project. I was tasked with writing a program that uses keyboard input to create two-pole filters and cascade up to 4 of these filters. I didn't really have much hardware here, it was just input pin and output pin, but I'll kind of walk you through my software. Initially, I request a lot of information from the user, like sampling frequencies, critical frequencies, filter type, radius. Then I actually select my numerator coefficients here based on their choices, output that, then I calculate my denominator coefficients, output that. Then I ask if they would like to remake the filter, cascade another filter, or activate the filters. Here's my interrupt sequence where I'm actually running the filtering process. You can see I do all the filtering, output it, and then I step forward in time. So here's what the program actually looks like. I start by requesting a sampling frequency, then have you pick a filter type, a critical frequency, and a radius, and ask if you want to cascade or start filtering. Here I'm making a low pass filter with a critical frequency around 25 hertz. So you can see that we've got good gain here at low frequencies. As I start to increase it, we'll see some attenuation. The next filter that I'm going to go ahead and make is actually a high pass filter with a cutoff frequency of 20 hertz. And it starts kind of quickly, but you can see that as I continue to increase the frequency of my input signal, which is in green on top, the output signal will actually start to get bigger as well. The next filter I'm going to make is a bandpass filter with a critical frequency of 25 hertz. And we can see here that we start at almost complete attenuation. Then as we approach the band, the gain gets large. And then on the far side, as we move away from the band, we'll actually see more attenuation again. The next filter I'm going to show is my band reject filter with a critical frequency of around 25 hertz. And this obviously moves in the opposite way of the band pass, where we'll start with pretty much full gain. And then as we approach the 25 hertz, we'll see attenuation. And then as we continue on to large frequencies, we will see the gain return. And the last filter I'm going to show you is a actually cascade of a low pass filter with a cutoff frequency of 30 hertz and a high pass filter with a cutoff frequency of 20 hertz. This kind of makes a band pass filter. I wouldn't. I was going to show more cascades, but it gets kind of chaotic, so I just decided to show the two working together. And we can see that at low frequencies we get attenuation, and then we approach into our band where we get full gain, and then on the far side the low pass filter will cut off our output. So here I'll kind of walk you through some of the logic that went into the inputs section to basically make sure that all the inputs are valid. I kind of force the user to pick a sampling frequency greater than 0. I make sure that it's a number chosen for the filter type here rather than a character or anything. I make sure that the critical frequency is less than half the sampling frequency, but still greater than 0. I don't allow the user to enter a radius above 1 or less than 0. Uh, when you get to the end of your filter creation, if there's something you don't like, you're allowed to remake your most recent filter. Otherwise, you can press cascade and start making another filter. And here I'm just kind of going through and cascading 4 different filters together. And then at the end, I try to cascade a 5th, but it says you've reached your limit and it begins the filtering process. I had a lot of difficulty actually kind of trying to figure out what the gain of these filters was. And I think if I was to continue work on this project, I'd want to be able to calculate the gain in my code so that I wouldn't have to mess with the wave generation size, generated wave size. I also think it would work a lot better to do these inputs through a graphic user interface rather than the command line because it's just kind of clunky and if you mess something up, it's kind of hard to tell sometimes. So thank you guys for listening. And are there any questions?